Hello chemistry people, Amy here. I'm just making this video to talk through three concepts that are really important for particularly diploma level data analysis. So I'm going to start with concordance and then move on to accuracy and precision. So I'm just going to flip my computer around and we'll get started. Concordance. I'm going to start with a little bit of a mythology lesson. Concordia was the Roman goddess of peace treaties and agreements and basically happy marriages. There was that sort of overtone to like her domain as well. So Concordia was the goddess of basically agreement. Now, in chemistry, and I believe I've asked you to do this on practicals before, you've been asked to determine the concordant results. Now, what that means, let's say I do a titration and the three volumes I get are 14.50 cm3, 15.00 cm3, 14.45 cm3, and 14.55 cm3. Now, even though there isn't much of a difference, this answer is clearly not agreeing with the others. This is a non-concordant result. So in a question where you're doing a titration or you're performing the calculations from a titration, or you're doing an experiment and you need to analyse your results, the values that you average to carry on with in your calculation should only be the concordant results. So if you're going to calculate the average, you should only average the 14.50, 14.45 and 14.55. Because adding in that 15 would skew your average. It would be like averaging the ages of the people in our chemistry class and including me. I am a non-concordant result for that data set. This is why we do multiple trials, so we can go through and eliminate those non-concordant results. We perform at least 3 trials because hopefully you would always get at least 2 of those to be in agreement, to be concordant. So this is why we perform those multiple trials. And that's so we can get that repeated value, although that repeated or close to repeated set of values. That should enable us to get a better result at the end. Okay, now there's a reason I've got bullseyes over here. Let's talk about accuracy versus precision. So I'm going to switch to red and let me just check. Yes, that is appearing over. So accuracy versus precision. And this does link to the idea of concordance, but in sort of everyday English, accuracy and precision are pretty much translated the same way. They mean the same thing. However, in chemistry, accuracy is closeness to the true value. So this is related to that percentage error. that you might calculate as part of a practical report. So an accurate set of results might look something like this. So you might get one smack bang on the target, but the others are all over the shop. Because there is that one that is close to the quote unquote true value, this is an accurate set of data. Precision, on the other hand, is consistency. So the consistency of the results, I should specify. So for example, a precise set of data might look more like that or like this. These results are consistent, they are precise, but they are not accurate. That's the difference between these two. Accuracy is closeness to that true value. Precision is about the consistency of those results. Hopefully, you should now be able to see what an accurate and precise set of data might look like, and that is, so that is an accurate and precise set of data. It is close to the true value and those results are consistent. So with accuracy, so this closest to the true value, accuracy tends to be able to be improved by going for more precise equipment. Because remember, all of our equipment is plus or minus. So if I measure out 20 cm3 plus or minus 1, that means that I can have anywhere between 21 and 19 cm3. I can be both above and below that value. So what if this value is where it's +1 and this value here is where it's -1? Over here, this is a problem with your method itself. Your method is working beautifully in terms of having all of your results really tightly grouped. It's just not getting you the answer you're looking for. So is there a consistent place where that method might be throwing you off? For calorimetry, is there a source of heat loss that you haven't taken into account? Is there a problem with the way you're calculating your concentrations? Is there a consistent flaw in this method that would always be skewing the results in a single direction? The goal is to get accurate and precise, but it isn't always doable. So ideally, we would always design methods that are both accurate and precise. Sometimes by the limitations of the equipment we've got in our labs, we can't do it. Sometimes it's particularly complex reaction mechanism where there's things that we can't control properly. Okay. So that brings us to the end of our quick little discussion on concordance, accuracy, and precision. As always, I'm open to answering questions, so you can either leave a question in the comments, or you can, if you're one of my students, fire me an email to ask for some more clarification. Thank you so much. Have a fantastic rest of your day, and I shall see you next time. Bye.